All right, excuse me, welcome back to Chapter 7, Lesson 6. Now we're doing our second video here, and we are once again solving one-step equations. This time we're using multiplication and division. Here is a bit of a difference in what we did with regular equations. In inequalities, the rules are exactly the same as they were in equations, except for now. If you're going to multiply or divide by a positive number, your symbol will always stay the same. Pretty easy. Here, in this example, we're multiplying by positive 2, and notice these arrows all face the same direction every single time. Now, let's go ahead and look at the second example here. We have a negative number that we are dividing by here in red, as you can see. Now, what happens here now is whenever you end up multiplying or dividing by a negative number, when you're dealing with inequalities, you're going to cause the symbol, the inequality symbol, to flip direction. So here, we have negative 4 is less than negative 16. That is a true statement. Here they divided both sides by negative 4. Negative 4 goes into negative 4 one whole time. 16 divided by negative 4 is a negative 4. What we had here was a negative number that turned to a positive, and a positive that turned to a negative. And that's all because of this division right here. So whenever you multiply or divide by a negative number, this symbol has to flip direction. And that's exactly what we're going to practice right now. So let's go ahead and scroll down to our next or third example. Let me go ahead and remove that green circle off the screen, since that's kind of annoying and not needed right now. So here we have an inequality. 2g is less than 10. I'm going to make a little field here for myself to go ahead and write and do work on. And clean it up, adjust the location, and we'll get right to work. So our instructions are as follows. Solve each inequality, represent the solution set on the number line provided. Here's our inequality. Negative 2g is less than 10. So first step is always to rewrite your problem. 2g, or negative 2g, excuse me, is less than 10. Now, let's repeat our process just like it was for equations. Identify your variable. Our variable is the letter g. What's happening to letter g? Letter g is being multiplied by negative 2. Well, what undoes, or what is the inverse of multiplying by negative 2? That would be to divide by negative 2. In algebra, we show division with a fraction bar. And if you want to use the actual math term, it's called a vinculum. But you go ahead and keep calling it the fraction bar. Now, I want to get rid of this multiplying by a negative 2, and I do that with the opposite, by dividing by negative 2. So here, I have negative 2 divided by negative 2. How many times will negative 2 fit into negative 2? It'll fit one whole time. And then the letter g just comes right on down with it. My symbol, I'll work on that in just a second because I want to deal with the second number. 10 divided by negative 2. If I'm dividing by two numbers with different signs, like a positive and a negative, I know my answer is going to be a negative. 10 divided by 2 is 5. Now, according to the rule above, whenever you multiply or divide by a negative number, this sign has to flip direction. So that's what I'll do here. To make my answer finally complete, I can go ahead and erase the 1, because we already know that this is just a single letter g. It's 1. Alright, so you guys heard the bell just rang, but that doesn't matter, I'm going to keep recording. So I'll go ahead and finalize my answer, and what I have is then just the letter g. Whoops, you get it right a little better than that. G is greater than negative 5. So let's see what that's telling us. Let's say, first of all, that we have our number line here. Okay, it's telling us all of our answers, or all of our solutions, have to be bigger than negative 5. So here's 0, here's negative 1, 2, 3, 4, 5. Here's negative 5. All of our answers have to be greater than. Notice there's no equal sign here, which means I'm going to have an open circle, because negative 5 is not considered to be one of our answers. And everything that's bigger or greater than negative 5 is in this direction. So I'm going to go ahead and pick a number on this line. I'll pick my favorite number, which is 0. I'll plug it back into this original equation. Negative 2 times g should be less than 10. If I put in a 0 there, that becomes negative 2 times 0 should be less than 10. Negative 2 times 0 is 0. Is 0 less than 10? Yes, that's correct. But let's say you made the mistake and didn't turn the symbol around. You would have ended up with the wrong answer of this. G is less than negative 5. You may not think it's a big deal, but let's try it. Let's say I picked a number that's smaller than negative 5, like way down here at negative 10. So I'll try in a different color to solve this exact same equation, or inequality again. But this time I'm going to plug in a negative 10. Negative 2 times negative 10 is less than 10. A negative times a negative is a positive. And now I have the statement that positive 20 is less than positive 10. That is false. So just by not switching this arrow around, all the answers I would have gotten would have been all wrong. So whenever you multiply or divide by a negative number to solve an inequality, your symbol must flip direction. We will practice some more right now. Let's go ahead and move on to the next example. All right, so moving on to example number 4. X over 3 is greater than or equal to negative 4. So I'll go ahead and make some space to do my work. Let me clear this out. Readjust. All right, now we can start. First step, as always, is to rewrite your inequality. X divided by 3 is greater than or equal to negative 4. Identify your variable. My variable is the letter X. What's happening to it? It's being divided by 3. What undoes, or what's the opposite of dividing by 3? That would be to multiply by 3. So I'll multiply the left-hand side of my inequality by 3. And whatever I do on the left, I have to do on the right-hand side. So here, I multiply times 3 on the left and times 3 on the right. Now, whenever you have a number like X or a variable, and you multiply it, then divide by the same exact number, you get a 1. So this is 1x, greater than or equal to. A negative times a positive is a negative. 4 times 3 is 12. Now, notice that I did not switch signs. That's because when I multiplied in this case, over here, I was multiplying by a positive number. You only flip the sign if you're multiplying or dividing by a negative number. So, to finalize my answer, x could be any number bigger than or equal to negative 12. But like always, I want to make sure I am doing it right, because you may not be too sure about the sign flipping yet, so you should always test your answer. Since we're required to graph our answer on the number line, I have to make this anyways. So here's my number line. All my answers have to be greater than or equal to negative 12. So I know I'll put 0 like over here, and maybe I'll count by, let's say, 3s. So here's negative 3. Then I'll move a little down a little more, negative 6. Then move down a little more, negative 9, and then down here I'll have negative 12. You can count however you want, as long as you make it consistent, which means the same. Now this says that all my answers have to be greater than or equal to negative 12. Since negative 12, since it can be equal to negative 12, I'm going to use a closed dot, because closed dots mean that that number can also be a solution. And negative 12 is considered to be a solution. All my answers have to be greater than negative 12. Well, everything is bigger going to the right. So anything on this number line up through positive infinity will be included as an answer. We should always check our work. So I'm going to go ahead and do that down here in this next space. My equations, my inequality said x over 3 is greater than or equal to negative 4. I'm going to pick a number on this number line. I'm going to use my old friend. Instead of 0, I'm going to go ahead and use, let's try negative 3. Negative 3 divided by 3 should be greater than or equal to negative 4. A negative divided by a positive is a negative. 3 divided by 3 is 1. Is negative 1 greater than negative 4? When I look up here, negative 1 would be like about right here. Negative 4 is way down here. So yes, negative 1 is bigger than negative 4. So this is a true statement, which tells me that everything I did here was correct. If you don't believe me, pick a number on the other side of negative 12 and plug it in here, and you'll see that the answer you get will not be true. Now, if you have any questions about this example, once again, write it on the side so we can address it in class before moving on. If you feel that you already understand this enough, then go ahead now and work on the got it section here and work on C and D. Make sure you create your number lines after the fact, after you've solved all this, and I would suggest you do it on a separate sheet of paper. To quickly review, just an important little note here, I want to scroll back up over here to the side and see if I can just scroll over here to the right and look at this little side note we have. In example 4, you do not reverse the inequality symbol even though the inequality contains a negative number. The number by which you are multiplying is positive, so the inequality symbol remains the same. This is exactly what I just told you. Unless you're multiplying or dividing by a negative, your sign will always stay the same if it's positive. Doesn't matter what you're doing. So only when you multiply or divide by a negative number does your sign flip. And you should probably make a note of that, and I would even suggest maybe making a big note down here. A very important note, put a star on it, something that has to do with that rule. Write in your own words so you understand. If there are no further questions, then we will begin discussing this lesson with you in class. I hope you guys enjoyed this video a little more, and if you need any help, please come see us anytime. Thank you.